We're now going to turn our attention to key concurrency and scheduler operators that appear in RxJava in the context of the single class. These operators arrange to run other operators in designated threads and thread pools. And we'll be talking here about the subscribe on operator in the single class and the single operator in the schedulers class. The subscribe on operator is used to run subscribe, unsubscribe, and request on the specified scheduler worker. The scheduler parameter that's passed to subscribe on is used to indicate what thread to perform the operation upon. The subscribe on operator returns the single that's requesting asynchronous processing in the designated thread. The semantics of subscribe on are actually a little bit unusual, so we'll take a look at an example to make it more clear. This example comes from the case study that we'll talk about in more detail at the end of this lesson. If you place the subscribe on operator somewhere in a chain, this impacts the execution context of the onNext, onError, and onComplete signals. So for example, if you look at the chain of operators here that start with single from callable, we're going to use from callable and the factory method operator that it provides in order to be able to reduce an unreduced fraction. We're then going to use the subscribe on operator to indicate that that processing and all subsequent processing will run in a background thread, which will be defined by schedulers.single. Then we use do on success, map, do on success, and ignore element. And all of those operators will run in the context of the scheduler's single thread that's designated by passing that as the parameter to subscribe on. Now, it turns out you can actually put subscribe on later in this chain and have the same effect. So we can put it right after from callable, we can put it right after the first do on success, after the map, after the second do on success, and so on and so forth. And it will always run all those operators in the thread designated by schedulers.single. However, it turns out if an observe on operator were to appear later in the chain, that would change the threading context where the rest of the operators in the chain below it will execute. Keep in mind that observe on can actually appear multiple times in a chain. We aren't going to look at observe on right away. We'll come back and take a look at that later, but just be aware that the semantics of subscribe on and observe on are a little subtle, especially when used together. Project Reactor has a mono class with a subscribe on operator that works the same way that RxJava's subscribe on operator works on the single class. Let's now turn our attention to key scheduler operators in the single class. In particular, we're going to take a look at the scheduler's single operator. And this hosts a single-threaded executor service-based worker that runs concurrently with respect to the caller. So here's the same example we looked at before, except now we're focusing, instead of focusing on subscribe on, we're going to look at schedulers.single. And that's just an indication that you want to have all that processing run in a single background thread. And single will return the single background thread that will be used for running in the background. We'll take a look at this in more detail again when we look at the case study at the end of this lesson. Schedulers single is optimized for low latency calls that all run in one and only one background thread. Of course, there are other ways to make new threads, but if you use single, you'll always get back the same background thread. Internally, this is implemented via something called a daemon thread. And what that means is the app won't be prevented from exiting even if work running in the daemon thread isn't finished when all the other non-daemon threads go away. That's essentially the semantics of daemon threads. Project Reactor has a schedulers class that also has a single operator that works the same way that the one from RxJava does. So this is the end of our overview of key concurrency and scheduler operators related to the single class. We'll talk more about other operators later when we get further on in our single lessons.